Good evening, friends. Welcome to Eason Academy. We are into embedded systems design. We are discussing as a part of embedded system programming. Today is session 5. And today we're going to discuss about a nice topic which will be useful to you later days for you. This topic is about embedded system hardware firmware software partition. That's a slightly unique topic. Generally, you need to understand about what is embedded systems and how do I design it. This will be very useful later when you start doing a product design or something. So it's a very generic topic. Don't get too much worried about the topic. It's a quite simple and generic topic, what it does. So let's get into the board. So what is all about? We are very clear about electronics. First, let us be very clear about electronics. Electronics takes input, it gives output. That's it. And we do process. This is electronics. It takes electrical input, electrical output. Never forget this. This is electrical input, electrical output is called electronics. And there are so many methods. We have discussed actually called board design or chip design or embedded, whatever method you can do that. And you have some other input, maybe mechanical, chemical, okay, or heat, or wind, or light, or sound. All these things has to be converted to electrical. First of all, these are called sensor. Same way, this electrical output may not control your motor or heater or speaker directly. You may be having a device called either drivers or amplifiers. You cannot do them directly. And within electronics, we have discussed that the three methods, and we are discussing about embedded. And there were three things. One is called discrete. We use the loosely components and make them as a circuit, or we use the IC. That is, we put everything on a single IC and do that. In IC, there are three types. One is called ASIC. A IC which does only one purpose, or FPGA, where you can configure the circuit as you wish. And last one is microprocessor, where you write a program to do that. It's actually a computer. That means that within electronics, you put a computer. That's why we say that software is must. And the last class, we had discussed this difference between what is the difference between doing this ASIC, FPGA, or embedded, or microprocessor. These two are same. The only difference is this is flexible, this is application specific. Everything is fixed. This is fixed. This is flexible. But these are called hardware. Reason is you make the connections permanently, but whereas this is called sequential device. You do one by one. So the thing is that to do your work, if you have to do 5 tasks, this microprocessor will do 5 tasks one by one. Whereas this ASIC and FPGA will do the task all the 5 parallel. So each one takes 1 minute. it takes only 1 minute. Whereas here, it takes 5 minutes. So please understand, this microprocessor based system is always slow. And ASIC and FPGA are fast. So now we have a problem. In electronics, we have discussed that we take the input and give an output. We have an input and we have output. In the case of embedded, we have a microprocessor which executes your software there in the thing. The biggest problem with this embedded design is about cost. And second one is about heat. Why I say heat is, if you use a high speed microprocessor that produce more heat. Because of the more heat, people put the heat sink or fan or a cooling system. But these things are not possible on an embedded product, which is going to work on a shop floor or with the machines or at your home, remote or everywhere. So we cannot use high speed. So we have to use low speed. That's the first problem. Second problem is cost. And embedded system is basically a small electronic products, which people are worried about the cost. It's a very cost conscious market. Here is the problem. Because of that, you will be using a low performance microprocessor and less memory, ROM and RAM. ROM is the one your software is there. RAM is the one which is your variables are stored data. Now you take the input and give the output and you process it to the software, then it becomes slow. For example, you press a button here and you want the output light to be on. The timing is very important. That's what we draw like this. This is input, this is output. What is the time? Normally it's fine. In your case, in your keypad, you can press only one press per second. So by the time within 1 second, you do press next time after 1 second. Within 1 second, if this guy could be given output, then it's okay. But sometime, let us take a small case. Don't get confused here, but I'm giving you a small idea. I have so many objects are coming in a conveyor belt. So many objects are coming. And here is a sensor. That sensor is sensing and giving it here. Whenever the object crosses, I do that. Now, when I'm doing this, when the first object comes, the pin is going to change from 0 volt to 5 volt because there is a sensor. Here is a sensor. Here's a light. When you block the light, then the sensor will sense it, then give you the voltage. That we will see it on the electronics class, how that is happening, how the sensors are working. Understand now? So when there is no object, light is going to fall on this, I get 0 volt. The software will be reading this pin as 0 volt. That's what embedded. Now, when the moment the object comes here, it's blocked. Then I get here 5 volt. That means that the pin is changing from 0 volt to 5 volt. That your software will detect. That is what we are going to do it on embedded system programming class and exercises. Okay. Like how you are performing the C programming, that time we are going to perform the embedded system programming. There you will learn a lot, how exactly these things are working. Now I'm giving the idea of how, why these things are important. Why our class embedded system programming is important, why, how the industry is looking for. Now I have a display here. You understand? I have a display here. I write a software. The software will detect the count. Okay. Then I'll be reading the pin. I'll say while the pin equal to 0. I'll be here. The moment the pin is 1, I'll break. I'll get out. Then I will display the count. I will increment. If it's previously 25, I'll increment to 26. Am I right? That's a small idea. So you keep on incrementing the display counter whenever there's a count, whenever I cross a count. The problem is I do this while function, then I do a display function. Am I right? I do 2 things. First of all, I'm waiting in a delay. The moment the object is identified, then I go and display the number. But there is a problem. I should do that before the next object comes. Understand that? Before the next object comes, I should do the thing. If I have got some other work, if you have to display something out, or you have you press another key. If I'm doing some other activity, then I will miss this count. Can understand? Let's assume that you are talking to me and somebody's phone is ringing. If you don't pick up the phone, you lose the call. Am I right? So that's all. You've lost. That call is lost. The same thing's out here. These objects are coming so fast. Within that time, I should be ready and I have to wait for the pin once again. But due to some other activity, if my program don't come here, then I've gone. Am I right? That's the problem. That's the problem we face. Then only people have done something on a hardware to count, or we call counter. This is called hardware piece, where it will do the own job. And when I come back, I go and read it. This guy will be incrementing. Whenever there's an object comes, this guy will be incrementing. It's nothing to do with your microprocessor. Understood? Your microprocessor, my ROM, and your software can do some other activity. This will be happening in parallel. This I give a small example. For example, there are issues. The issue is that I have a SD card. And the SD card, you have a MP3 song. You have a MP3 song. You have to read the MP3 song. And you have a microprocessor or microcontroller. It is microprocessor within the microcontroller. Then you have a speaker. So you have to read the song, and you have to. This is a compressed. This is MP3 standard called compressed. Now I have to do the decompression. Then I have to play back. But the beauty is, while I'm playing back, the timing should be very important. If the timing is not right, then the song will be played totally different way. Either it will be a lengthy one or shorter one. So that does not work. You have to give it the exact timing. Okay, that's we will discuss how they do the thing called sampling. Sampling and get out of the same sampling. If I sample at 8 kilohertz, I have to give out the same 8 kilohertz sampling. You might have studied in the college called Nyquist theorem and all. Nothing, don't worry about that. That is, we don't use the serious Nyquist theorem. We will be using that in digital. How do you do that? How do you do A to D, ADC, and DAC? How do I process? That you have to understand what it is. As an embedded engineer, what is that? So what I'm trying to say is that I have to read from SD card and I have to put it on the speaker. These two have to be matched. For that only, your decompressor software, if you run it on the microprocessor, microcontroller, it becomes slow. It becomes slow. So you cannot achieve the speed. For that reason, what we do here is this is a small project which you can try actually. It will be very nice. MP3. Here is a microcontroller. Here is a SD card. And here is a speaker. Then you read from SD card and give it to the MP3 controller. And get it back and give it out. So you are, no, what I'm trying to say is that first what you have to try is this, as we mentioned, that is first write a passive program. Learn this, master it. This is a level 1 on embedded. Level 1 on embedded. That is, you should know how to control LED, 7 segment, dot matrix LED, switch, keypad. This you should be thorough. You should not have even a 1% doubt on this. Once you have done this, then second is use controllers. That we have various types. In the controllers, we have various types. Start with first one is timer. Second one is LCD. And third one is interrupt. And it goes like that. So I'm trying to say that why you have to learn this, because this is what your life. This is going to be initially this is 100%. And this is 0%. You're going to do this. But slowly this will change. In your real life, this is going to be 1%, this is going to be 99%. This is going to be 1%, this is going to be 99%. Okay. And there is a trick you should know. Using this for LCD or timer interrupt, you should be able to write functions. So that's why I'm repeatedly telling that master in C programming all these things. Then you will handle it so easily on embedded system programming. You understand? So both are same. The only difference is here, you are going to do it on the keyboard and monitor. And here you're going to deal with the LCD, timer, interrupt, everything. They're all simple. We can discuss them. Don't worry about this. When you started doing the embedded system programming, things will become very clear to you. But these are the very important things. So what is happening today is this a trick. People generally find out that how much time it takes your processor. That is what they call MIPS, million instructions per second. Million instructions per second. That from that they will find out that my software will take for the input output so much of time. Because of that time, I cannot process this. So then only you will go for 32-bit processor, high speed, everything. This all depends on that. How do you what is your requirement? But things are requirements are going too much. For example, take a very simple thing. If you put a fingerprint sensor, if you put your fingerprint here, this guy should read it and Do the activity, open door. This time is very important today. It is very important today. Okay. This is what you will not be realizing right now, because right now you are in functionality. Maybe the same lecture, if you listen to me on the next batch, you will get to know more, because by that time you could have really understood a lot about embedded system programming, everything. Second thing is performance. Third one is reliability, which I told you already. This is have two parts. One part is on the software side, what you are doing, where you make sure that always learn to write a perfectly working software without testing. Without testing your software, you should never tell anybody that it's okay. Writing a software is not important. Let us say, for example, if I say that, if I ask you that, check a digit, 4-digit number, okay, 1573, and add these numbers. If the number is less than 10, do some activity. For example, now you should give various inputs there. You should give various inputs: 1573, 4561, 2513. Should give various inputs. And what is your output? Appa, I have done everything. I have done about 10-20 samples. It is working. So this is what the problem statement. This is what I have given a program. And this is what output. So after the problem, you give an input and output and check, correct. This is a problem statement. It is validating. Without doing that, don't send the code to anybody. Right now, you think I'm a manager, but when you go to a company's, your manager should say that, oh God, good man, Balaji's problem, whenever Balaji gives, there's no problem, and he tests everything perfectly and send it. If I just write a program and give it to him immediately, then he will say that, Balaji, your problem is given to people, and everybody is saying that few problems are there. That's the thing. So that is what the reliability. Never give a problem, release a code. As long as the code is with you, no problem. The moment you give it to someone, that should be tested by you. Without properly testing, don't release the code. That's the rule of the code, rule of the game. Then we will write a small code here called test software. That will test much more combinations of your software. Then it will make sure that it's working. But what right now I'm discussing is neither this, not this, not this. I assume that you have understood the functionality. Now I'm discussing performance. The performance is solely depend on two things. One is cost. Other one is size and so many things. Size, heat, so many things. So if I have a low cost and small size, less heat, my performance will become low. But if you are an engineer, a true engineer, with this criteria, this is what normally when I'm working in a company, they will give you these things. With this criteria, I will design a product, or you should design a product that should work. That means that you will use a low speed microcontroller, but you'll be using some other hardware controllers. Sometime, I'll give you idea also. Sometime what happened? Everything is becoming embedded nowadays. Please understand. All are becoming embedded nowadays. That's a trick. Okay. The thing is that you have a microcontroller. This microcontroller is having so many controllers inside, apart from ROM and RAM. Now you have some other controller. See, controller is nothing but, I told you already, don't think big about controller. It is nothing but you have a driver, you have a cook, you have a typist, like that. They are all a specific job. They are like a same human only. The only difference is somebody will be managing them all the activities, and they will do only one activity. The controller is same like as equivalent of a microprocessor, but it does only one activity. So that means that, let us assume that I have a microprocessor and I have a ROM, I have a RAM. I write a specific program which is already there, which you cannot change. Then this became a controller. We are going to design our own controllers in coming days. If you have a time, that's why I say that stick with me for a long time, then you will be able to design your own controllers with me. I'll give an idea of how to design a controller. Then you will be able to get into the market so well. You also have two problems. You have to learn a lot. You have to learn a lot. That is the first one priority. The second priority is you have to get the job as early. You cannot keep on learning for years together and waiting for the job. No, you should also, this is a compromise which we are discussing now. Understood? Of course, after you get into the job also, you can be with me. You can learn continuously. That will help you when you're working in the company also. That doesn't matter. So there were three things. Understand one thing. There are three things. That is, I buy a microcontroller. Which is having built-in controllers. These are called built-in controllers. Am I right? At the same time, I want to do some controlling on video or something. The controller is not available. I will search the net. I will search the companies. There will be some other company maybe having outside controller. This is called external controller. They separate IC. This is one IC. This is another IC. I connect them. That's what I told you, that how do I connect? Either I2C or SPI or CAN or whatever it is. So many things are there. USB, any way I can connect. So understand that we have a microcontroller IC. It's having built-in controller, but unfortunately, my requirement is not supported by this guy. Then I buy another microcontroller outside. So I do that. Second IC. These are all the things you should know, that which are all available in the market. Today's your job is not only technical. You also should know that what is available in the market. And how to get them, how to use them. How to use them is very easy, not very difficult. Once you learn one or two controllers, then all are easy. So, for example, you may be spending about 2 months. You may be spending about 2 months to develop a software. But that controller may be already available in the market. Understood? Then your manager will ask, hey Balaji, what you have done? It is already there. Why you have to spend so much of time on this? Am I right? I should have a justification. No, sir, this is very expensive. This costs about $100. So every product I have to spend about 7,500 rupees extra. But whereas if I develop the same thing, it became very cheap. Then if you justify that, why I have to do it on software? That's what the trick. Now, so there's a third one is there. That's what I want to discuss with you. The third one is this. That is, the first one is you have a built-in controller when you decide to do it on the offload it. Second one is you will be doing it on the external controller. Now there's a problem. There's a third problem comes. I cannot do it in software because this is slow. I cannot do it. So this is ruled out. At the same time, At the same time, I could not find a controller. It's not there for market. I have a requirement. I have to take the picture from camera and just be processed with a specific requirement. For that, there's a controller is not available. It is wise to buy the really available controller. It will save you a lot of time on building a product. So, at the same time, I cannot develop it in software because that will become very slow. So, software is ruled out and controller is ruled out. That is the time company decided to do the whole thing in a FPGA. You know that when we use the FPGA. So, what will happen is there'll be a FPGA will be there in your design. There'll be a FPGA will be there. There'll be a team called IC design team. IC design team, they will use the Verilog and then download the code of the Verilog. It will work for your requirement. This is your IP, intellectual property, which this product, nobody can make it except you, because the controller is not available and they're slow. And you have developed this for 1 year to develop this FPGA. You can do either you can sell this FPGA IP to somebody for money, or you can sell as a product. So this is what the trick. So please understand, when you are getting into the performance, somehow you have to get it, the product. Somehow you have to get the product with the performance. For that, we use all these methods to do that. That there's nothing called here which is right, which is wrong. This is generally called software hardware partition. We decide that which are all the functions are going to be done on software, which are all the functions are going to be done in hardware. Generally, this is called control plane. This is called data plane. What is the meaning? I'll tell you. I'll tell you what is the meaning of control plane and data plane. I have a water tank. The water is coming through the pipe. And here is the tap. The water is coming here on the vessel. Now the tap is having a control. Am I right? The water is flowing through the pipe continuously. Nobody is taking the water or do anything. But we use the tap to regulate the water. That is what this. For example, this. I'll give you the simple idea. We all know that. We all know that this idea. A product. Let us assume that in your company is having so many machines. So many PCs are there. So many PCs are there in your company. And you are getting an internet from outside. You are having an internet from outside. And it's a very high speed. And whatever coming here, and this get distributed to all the people. Okay, let us assume this is a switch or router, whatever you call. Now, I wanted to do the check here. I don't want any packet coming from Facebook. Let's assume that I don't want any packet coming from Facebook to here or Google or WhatsApp. You know that. I should have, as a company manager, I find that, hey, people are during the work hours between 9 to 6. A lot of people are watching this Facebook, which I don't want. So cut the Facebook. So what this hardware will do, What this hardware will do, it will open the packet, your Ethernet packet, and check for the IP address. Check for the IP address. If the IP address is from Facebook, okay, you know that everybody is having a fixed IP address. So Facebook is also having a fixed IP address. If you go and search the thing, facebook.com, you will know that. That's what they call DNS, domain name server, which gives you the IP address. Now, what will I do here is, I remove the, because I worked on the product. Please understand, these are all called embedded product. These are all embedded products. I worked on a product which is exactly called monitoring the whole packets. We will get all the thing. From there, you will tell topper. These are all, we did everything in the hardware. Understand the thing. That's why I'm explaining you that the product was done, which is called embedded. Okay. That company is looking for a lot of engineers. These are called, this field is called network engineering. That means that you should know networking, you should know embedded. So embedded plus networking. There's a huge gap. Most people don't, all the people, those who are networking, don't know about embedded. The people, those who know embedded, do not know networking. Now you know that the other field is coming, IoT. That is also embedded plus networking. So this is all wide, huge power. There's a huge market, man. I don't know. I could not say more than that. Okay. Now I know I'm trying to explain to you that what is that. So, for example, if I open if the packet comes here and go to software, and the software open the packet and finds out that what is IP, then give it to the your switch and come to you, you will become very slow, which you don't like. So what we do here is we implement the whole thing in hardware, controller. There are controllers. The controller will look for the what? I will tell the controller, hey, this IP address. That's it. Then whenever the IP address comes, that guy will drop the packet. That packet will not come inside. So now the software will tell that which IPs, see that the software is going to tell him that which IP, this is embedded. Understand? Which IP to be blocked. But the opening the packet and sending the data is done by the hardware, the controller. You should know, as a embedded engineer, you should know how to program this guy. You do not have to know how to design this guy. No, that is not your job. Your job is what register has to be programmed, how to program. Okay, then that guy will block that. This is called control plane. This is called data plane. So better understand what is your, where you, what is your role. The embedded, all networkings are embedded, man. All networking are embedded only. All networking products are embedded products. Please understand. All networking products, you take switch, a router, this one. What do you call? Sorry. Set-top box. You take anything, all of them are embedded products. There is nothing called, for example, in your laptops, you put a small USB adapter for internet. That's also called embedded product. I'll give you one more concept here. Maybe the next session I'll explain to you that. Okay. So what I'm trying to say is that there is a hardware which goes on the path of the data. This is called high speed. These are generally designed by the IC engineers. But IC engineer will only make things possible. But who is going to use it? You. embedded people. You are the most important guy. You will say that what package you will have a registers here. You should know what to write here, such a way that the data will be blocked or go there, allow it or not, or read the statistics, whatever it is. You can do wonders. You can do wonders with this. This they manufacture IC in the factory, million ICs, let's assume. 1 million ICs. But everybody will buy it and do a different product. I buy it, I use it for different purpose. They totally depend on the embedded software. These are all, see, these are all called embedded software. Please understand. Okay, they are not, we feel, let's say that you buy your house, your router, your DSL router, for example. Okay, who will do the router? Okay, you do the fiber optic router. Fiber optic router. Then that whatever you do, see, there is no limitation of the embedded product at all. That's what I'm trying to say. But what I'm trying to say is that we limit what to be going on hardware, what to be in software. This is called hardware software partition. You as a person requirement keep on growing. The reason was sorry, there's somebody has asked a message. All C, all bottom level C. Everything is C software only. All these fields are all C. Only the top level applications are written on C++. All basically embedded software is all in C only. That's it. No. What I'm trying to convey now is why I've given a networking example. All the examples are all. This is what the fields exist. Don't say that where the hardware ends, where the software starts, because yesterday I was doing something in software. Today, they put that into the hardware and given to me. Now I written a software to do it on the control the hardware. So this field is gone now. Of course, this has come. So this change will be always taking place. This change will be taking place. Now, for example, think of a minute. I work in a company's product is called 100 gigabit Ethernet. You know that nowadays even 400 gigabit has come. That means that, see, think of it. If it is 100 gigabit means, what's the data size? That is, you have, this is 1 bit is about 0.1 nanosecond. So 0.01 nanosecond. Or you can call about in 10 picoseconds. See that 10 picosecond. That means that 1 byte means 8 bits. 80 picoseconds. Not even nanosecond. It's gone beyond nanoseconds. So let us assume that I have a microprocessor which is running at 1 gigahertz. Understand? My microprocessor is running at 1 gigahertz. Then to read the ROM, one instruction takes about how much time? 1 gigahertz means 1 nanosecond. So to read 1 byte, I spend 1 nanosecond, whereas this data is coming at 80 picosecond. 80 picosecond. My microprocessor can never handle this. So, same way, let us assume that you have a display. You say, I have a HD display. What is the HD display? 1980 by 1280. Am I right? Or 1920, whatever. I forgot the resolution a little bit. Forget it. Now, this means that how many dots are there? So many dots. Let us take 1000 by 1000. Please understand, maybe confusing you, but try to understand. Because every day you're using your mobile phone. 1000 by 1000. That means that your mobile is having 1 million dots. And you are hearing something, frame rate is 1000 frames per second. I mean, you are hearing that. That means that this many dots, and I'm doing it, this is for one frame, per frame. I'm doing 100 times. So multiply that, 100 million dots. I have to refresh your screen every second. Every second. Think of it, how fast your electronics should be. Am I right? That is what people say. You should know that. See, don't ever think these are all, you will be, the moment you join a company, you may start working on these products. Okay, don't think that this still your world is not with the on LED and blinking the LED. Those days are gone. We'll come to that next once you have done a embedded system programming first level 1. Then I'll tell you what exactly the industry is looking for. But this was much easier. Please understand. Don't get confused. They are easy, but you should know how we are doing it. So what I'm trying to say is that generally, please understand, hardware means fast, rigid or fixed. Software means slow, but flexible. So the product designers will do between these two very nicely. Understand? This is the beauty of the embedded products. So whatever hardware people do the FPGA, ultimately you need an engineer. Yeah, really embedded is the what? No, every product you do. See, to be honest, your mobile phone to computer, everything is embedded. I don't know, computer is also called embedded only. There's nothing. It's only nowadays all merged. Everything is merged. Your computer, there's no difference between a computer architecture, the mobile phone architecture, and the embedded system architecture. Okay, we'll discuss about the complex embedded system on the next session. Then you will know that how we do the that embedded systems. Okay, so effectively, what convey? I'm trying to convey only one thing. While you are learning ultimate, I say only one thing. While you are learning C programming, mastering, writing, and using functions. There are 3 types of functions. One is ready-made standard, third party, and third one is user. That is what you are going to write. Write your own function. Using is these 2. Okay. What is the difference between this and typical doing it? This thing is, there's a trick. When I ask you to do the embedded system programming, where previously what you have to do is you have to write a big program by yourself, everything. But today, you have all the things are available in the form of controllers. You should know how to give the command, get the work done. So now you have to know that you need not have to do. You should know how to give it and get the work done. Get the work done. That's a trick. Okay, this is the different ball game altogether. The ball game what we did and the ball game you are in are totally different. Please, you are going to play a totally different embedded game today. You start everything every time you start a programming, like starting from main and everything, it does not work. You should learn how to write 2 functions. But that is possible only if you are initially spend time on programming. That programming logic is correct. Yeah, exactly. That's what I'm trying to say. Predefined. That's all. It's not called pre. Yeah, all the functions are predefined. That's it. It's all available. It's all available. Even embedded field. Now companies wanted you to use the predefined functions and get the job done faster. But to using a predefined function, you should have a good programming ability. That is what which I'm trying to push you into the so many the C programming because I want you to be very fluent on programming. Without a fluency in programming, you cannot see. Just because you have a fluency in programming, okay, that doesn't mean that is what industry wants. No, industry wants you to use the functions. Why we want the functions? Because we wanted a lot of things to be fast. All those things are put in the special hardware called controllers. Okay, that's a trick. So don't get too much confused about this session. I'm giving you the idea of where we are going today. You should know that where are you today. Without that, if you start traveling, no, man. Delhi, I only go by walking. Walking is good, man. That's the way you learn walking. But that doesn't mean that you have to walk to Delhi. You know that how much time it will take. You better to fly. Am I right? That's what the functions and controllers. Better understand how to use the controller. In our embedded system programming, after a stage, after you've done an initial, I told you, these few things. That is, after the LED, 7-segment, dot matrix, switch, and keypad. Once you master this, afterwards, you need to spend all your time on functions and controllers. What you will do is you will write a function to control the controller. Later, you will use a ready-made function to use the controller. That's a trick. That is the function controller. There are two types. Firstly, you will write the function and control it. That is your user function. Then you will use the third-party function and the controller. This is easy because plenty are available. You can make a product at no time. But if you know only this, if it doesn't work, then you don't know how to use other things. That's why we ought to know everything. So this is what generally industry expects. That is, you should know this, you should know this, you should know this. Why we have done everything is because we are putting all the speed things onto the controllers to make things faster. Why we have so many controllers? Because I want better performance. If you do everything else, so what is happening is, instead of I do use the software for full function. Now, important functions are offloaded control high-speed functions. And software is becoming only doing a control activity. The actual function is done by the controller. Please understand. There's a big change now. Everything, every activities today have a controller. If that's why your life become going to be very easy at coming days. Well, the only problem in the software industry is that starting. Till you start using the functions and controllers, you have to do everything. This is what the beginner stage will be generally tough. But once you start using the controllers and functions, readily available function, you can do the product so quick time. That's it. Then you will know that what functions, how to use them, and that's it. There's nothing much logic. Here, fully logic, 100% logic. Here, there's nothing much logic. Here, how do you manage? So there's a big difference. Please understand. That's why I wanted you to cross the area as early as possible. But till you cross this, this is going to be a big task for you. You don't understand this, how the programs are written and how the functions are written, everything, you'll have a doubt always. But once you have done this, then this is going to be very easy. As I previously mentioned, this is what exactly happening in Python and Java everywhere. Okay, that's everywhere. You use the readily available functions. That's all, nothing more than that. So now I've given that's the reason I took the session today. What is exactly software and hardware in embedded products? And also when we make a product, there are so many things are involved. Let us say I have so many, let's do like this. I have a software, I have a hardware. And in the software, I may be using a lot of functions. And hardware, they'll be using so many hardware units. I integrate them. 1, 2, 3, 4, 5 unit. Then I integrate them. Now, first what I'll do, we'll get all these things readily available. Please understand, we don't write single piece of software. We buy everything readily available. We integrate them. We buy a readily available hardware, integrate them. And we put the software here and make a product. This is called prototype. Then, if things are working fine, then what we will do, we will take some pieces of the software one by one. We will localize. We will code ourselves. We'll make proprietary IP ourselves. This is called proof of concept, POC. This is called proof of concept. Today, so don't think things are all very difficult. The industry is very easy. The techniques, I'll tell you coming story one. So why I am telling you now is the importance of the software, importance of C programming. Then nothing can be done. If you don't know how to control these things, software, then you cannot do that. That's why I'm giving a importance to you now, as early as possible, master it. But next session, I'll discuss about how we are designing a complex systems. Okay, really high performance and complex systems. How do we design? That has to be the next thing. Not very difficult one. General ideas. Okay, it's all general ideas. That not going to do it tomorrow by yourself. Once you start developing your code and everything, that time you watch the videos or attend the next session, you will understand thoroughly much more clarity what exactly these things are all. Effectively, I want to convey you that all the products today are embedded today. You take any product, there'll be a embedded there. There'll be a microprocessor, there'll be a microcontroller, there'll be controllers, you'll be writing program. And everybody wanted engineers. That's it. There's nothing more to say about that.